And here we go. So let's start from the programming one. So just a reminder, our source code looked like this. So we have our main function right here, the whole thing. We have an if clause, then we have a for loop, else, and return. Let's look at that in Radar. So Radar 2 is the disassembler that we are going to be using this time, and R2 is just an alias for that program. Let's open it up. And now we get this scary little prompt. Let's try a question mark. And via this question mark, we always get some help, some options that we have. In this case, I know exactly what I'm trying to do. I'm trying to analyze this binary file. So we have analysis commands. And I'm going to cheat just a little bit. I'm going to put in 4 A's and just press enter, because I know that does the thing that I want to do at this point. And it also tells you what it actually did. It ran all these that you can see here. And now we just have to print the disassembled functions. And we want to see our main function. But how do we do that? Well, we can go through the question mark. We want to print something. We probably want P. So print current block with format and length. All right, P. Then a question mark again. Let's see our options. Here we have disassemble n opcodes. Let's see, PD question mark. And here we have disassemble function, PDF. All right, let's do PDF. Okay, this looks weird because this is not our main function. This is our first entry point. This is the text section that I talked briefly about in the stack image part. So how do we find our main function? Well, in this case, it's going to be fairly easy. We have the question mark. Here we can see seek to address. All right. S. Then we can actually type some sort of address. As you can see, here's our current address where the prompt is. So 0x0000580. We don't know the address of our main function, but Radar does. That's why we analyzed it. So we can just type in S space and main. Press enter. And there you go. Hopefully you can see that our prompt has changed. So we can actually use the PDF command and print our function. This is our main function. If you remember the source code, we had an if statement, something to do with the amount of arguments we gave it. We had a for loop there as well. And here you can see some of the strings. So here we have int printf const char. This is a call, so we call that function. We call the printf function, and what do we print? Well, basically the string above it. So in this case, this one, argv, and then the %s, which is the string, and here is the argc with %d, which is the digit. So this is inside the loop. And here Radar has provided us these nice little arrows, and we can see how the loop actually works. Here we have those jumps we talked about earlier. JL is jump if less. JMP is unconditional jump. We have compares. Okay, we have a bunch of different stuff. We know that this is our main function, but how do we actually read this one? Well, on the left-hand side, all this green thingies, these are memory addresses. These on the middle, these numbers and letters, these are so-called opcodes, OP codes. And what they are is another way to represent these instructions over at the right-hand side. So these are equal to these. And here, how do you read these? Well, we have the instructions here. We have some registers here and some other weird things like local underscore 14H, which is a D word, and we have a Q word, and so on and so forth. We have a bunch of stuff here. How do you actually read these are from right to left? So first we have our instruction. Let's take this one, move. We have a move instruction where we move stuff, we move values from registers to another. In this case, we will move from EAX to ESI, so from right to left. And every single one of these, add layer, which is load effective address, we have move, we have compare. We always check these from right to left. For example, in the compare, we compare the local underscore 14H to the value of EAX. And if we go back to the beginning, from the top down, what does it actually do? We can skip some of these, and we will, just for clarity's sake, we will skip all this for now. Here we have a compare. We compare the value 1 to value of local underscore 14H. And without knowing anything more, we can see jump if less than or equal. We will take jump to address 6F7. Let's see. Here's the arrow for it. It was 6F7, which is right here, which is the string too few arguments, and then we call puts, which is basically printf, which will print out the text too few arguments. So we can just make an educated guess what this whole ordeal actually does. Because in our source code, let's check that out. In our source code, we have this if statement. So if our argc is greater than 1, we go to the loop. But if it's not, we just print too few arguments. Fairly simple, right? So here we check exactly that. First we compare our argument count with number 1. If it's less than that, we print out too few arguments. Okay, what if it's not? What if we have enough arguments? All right, then we start actually doing stuff. First, we put value 0 into a local variable called 4H in this case. And then we have a unconditional jump. We jump to the address 6ED, which will be somewhere down here, right here. So we move the value from the 4H variable to our EAX register. Next, we compare some value from 14H to our EAX register. Then we have a conditional jump. Jump if it's less. And then we go to 6A8, which is back up right here. And we are now within our loop. So we do stuff, we print our argc with the printf function. Then again, we do stuff. Then there's our argv. We print it out. And then we add 1 to our variable. Okay, then again, we move the value from that specific variable to our A register once again, and then we do the comparement. And then we have a conditional jump, and we do it all over again until it's not less anymore. And then we take this unconditional jump and go right over here. So we empty our A register, because if you remember, all functions return their value to the A register, and we have return 0 at the end of our main function. So we put 0 to our A register, then we leave, and then we return. And that's it. That's how it works. It's way easier to read C code than disassembly. That's given. But if we don't have the source code, this is the option we have.